Hello and welcome to our channel. This is Gamow's puzzle series part 2, and in this video I'll be solving the question that I posted in that video. In case you have missed out our part 1, I have posted the link in the description box, would suggest you people to please go and watch that interesting problem. Well, let's start with this current problem. So the question goes like this. A man starts walking from origin of a rectangular coordinate system. His first step is of unit length along the positive real axis. I'm just going to mark the important things in this whole question. So this is the first important thing. He's starting from origin and then he's taking unit length along the positive real axis. He then spins on his heels through counterclockwise. So he's moving or spinning in the counterclockwise direction by an angle of theta and walks a second step of distance 1/2 unit. Then he spins on his heels through another positive angle of theta and walks a third step of distance 1/3 unit. He continued this process endlessly. Okay, so this is also important information. He continued his process endlessly. His next step, for example, is of distance 1/4 unit after spinning on his heels through yet another positive angle theta. Okay, if the spin angle is 90 degrees, then find the total distance traveled by walker. Well, first of all, let me tell you, this is not Gamow's puzzle, but yes, a question based on Gamow's puzzle framed by a very famous mathematician. The question is really interesting. How we are going to handle it through complex number, rotation, and vector form of the complex number, how we are going to see in this question. And not just for theta equals to 90 degree, we are also going to make some other observation in the question. So stay tuned. So let's start with the question. What I'm going to do first is, complex number means I'm going to start my question by first of all tracing the eigenplane. So starting with the eigensplane, assuming this to be the imaginary axis, this is the real axis. Now he start moving from origin. So he start moving from origin. So fine, let's start with origin. How he is moving? Origin say he's moving in the positive real axis direction by a distance of 1 unit. Then he spins by an angle theta in the anti-clockwise sense and moves by an angle, moves with a distance which is equals to 1/2 of the original one. That means half unit distance he is traveling in this direction. Again, he's spinning by an angle theta. Now he moves 1/3 distance. Then he again moves, spins and then moves a distance of 1/4, and this is how he's continuing his journey. Then 1/5 and so on. So this is how he is moving, and for solving purpose, what I am going to do here is, first of all, I'm just going to assume origin as O, and I'm going to mark these points as P1, P2, P3, P4, and so on. What can you say about OP1 vector? OP1 vector, the complex vector, can be written as 1. In the exponential form, I can write it as e per iota 0. Okay, similarly, if you talk about the vector P1, P2, this can be written as 1/2 e power iota theta. Why? Because we have obtained this P1, P2 vector by rotating OP1 in the anti-clockwise sense by an angle of theta, and obviously the magnitude has also reduced. Similarly, P2, P3 can also be written. So I'm writing third vector P2, P3, which is now of the length 1/3, but it is obtained by rotating the original vector by an angle of 2 theta in anti-clockwise sense. Let's write one more vector, P3, P4 also I'm writing here, which will become 1/4 e per iota 3 theta. So e per iota 3 theta. Fine. So this is how we can write down other vectors also, but these four are going to help us. Now, if I assume that P is the end point, P is the end point, then how we are going to write down the OP vector? Or you can say that the complex vector corresponding to the point P. OP vector can now be written by adding all these previous vectors, OP1 plus P1, P2 plus P2, P3, and so on till P3, P4. I'm going to add all these vectors, and at the same time, I'll also be using the property or the formula e per iota theta is equals to cos theta plus iota sine theta. So let's see what we are going to get in case of OP vector. OP vector will become all real terms I'm clubbing together. 1 plus 1 by 2 cos theta plus 1 by 3 cos 2 theta plus 1 by 4 cos 3 theta and so on till infinity. Clubbing all imaginary parts together will give me 1 by 2 sin theta plus 1 by 3 sin 2 theta plus 1 by 4 sin 3 theta and so on till infinity. So this is OP vector, which can also be represented as P theta. That means I'm representing it as P theta because I'm getting it in terms of theta. So P theta is this thing. Well, I gave you the question for 90 degree. I started my question with general angle theta so that whenever you want the answer for theta 90, I can put up the value of theta as 90. If you want the answer for 180 degrees, we can put it over here, 0, 2 pi, all these different angles. And now we have the common expression that we are going to use. So after calculating this P theta, which represents the complex vector corresponding to the end point, now I'm moving on to getting my answer for theta equals to 90 degree. That means the distance traveled when theta is 90. So chalo, let's proceed. So let's proceed means, first of all, now what I'm going to do is I'm just going to represent, first of all, this P theta in terms of sigma notation. So I'm starting with the P theta and I'm going to write it in the sigma notation form. You can write it as sigma n is from 1 to infinity cos n minus 1 theta upon n and plus iota n is from 1 to infinity sine n minus 1 theta upon n. So, well, this is very important. I'm going to mark it as 1. So let us mark this one as 1. Fine. Now what next? After marking it 1, I'm going to solve it for 90 degree. So the first thing that we are observing here is what is going to be the answer if you have theta as 90 degree or the angle pi by 2 radian. Very simple. Let's calculate. Putting theta is equals to pi by 2 here gives me the answer. So now I'm going to keep this theta as pi by 2. I'll start keeping the values of n. So observe carefully. We will be getting some of the terms as 0 and some will be left out. So what is left out is 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 and so on till infinity. And similarly, the second sigma sign wala terms, we will be left out with 1 by 2 minus 1 by 4 plus 1 by 6 till infinity. So this is the answer for P pi by 2. It is not representing the distance right now. It is only the vector that we have written. But yes, I want my answer in terms of the distance. So for that, I'm assuming this as A and this as B. What is A? What is B? Let's concentrate first of all on A. I would say that A is tan inverse 1. But how can we say so? Actually, we know the expansion or the series expansion of tan inverse x. It is x minus x cubed by 3 plus x bar 5 by 5 and so on till infinity. What you have done is you're just keeping x equals to 1 to get A. And that is why A is nothing but pi by 4. So now I have the value of A as pi by 4. Similarly, let us observe B. What is B? For B, you consider ln1 plus x expansion. We know the expansion of ln1 plus x. I'm writing it here. After writing this expansion, you can again see that if I keep x equals to 1, then I will be getting ln2. But B is not ln2 because on keeping x equals to 1, you are not actually getting B. Then what is B? Again, observe carefully. I can take 1 by 2 common and I can write that B is nothing but 1 by 2 ln2. So now I have the value of A, I have the value of B, and that is why now I can write that P of pi by 2 is pi by 4 plus iota 1 by 2 ln2. 1 by 2 ln2. What you need in the question is the distance. Distance of the endpoint from origin means nothing but the modulus of this complex number. So let's find out the modulus of this complex number. We are actually calculating modulus of P pi by 2, which is going to be equals to under root of pi by 4 ka square plus 1 by 2 ln2 ka square. ln2, we learn the value of ln2, which is 0.693. Pi, approximately, we take 3.14. So when you calculate this, your answer approximately turns out to be 0.858. Or you can say that approximately the answer is 0.86. So this is the answer for the question that I posted, but I'm not ending it over here. As I told you that we are going to make some more observation. So we will continue the question with some more observation. So answer for the question is 0.86, but let us proceed and see about the other observations. So going for the next observation. Now, what is the next observation? The next observation that we are going to make is for a different angle. What happens when you take theta as 0 or 2 pi? Actually, when you take theta as 0 or 2 pi, let us take the help of the graph. So when theta is 0 or 2 pi, what the person is doing is he keeps moving in the same direction. He's not changing the direction. He started from 0, moving in the positive real axis direction by a distance of 1 unit. After that, he stopped and again moving in the same direction. So here he stopped. Again, he is moving in the same direction, but now the distance that he is moving is half of the previous one. Again, he is moving in the same direction, but now the distance that he is moving is 1/3 of the previous one. And he keeps his journey in the similar way in the same direction. So you can see from the graph that what we are getting here is the total distance that he covered will be something like 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, which is the sum of harmonic progression, and up to infinity. When you calculate the sum, it actually tends towards infinity. So we can say that in the case when theta is 0 or 2 pi, the person is going to end up at infinity. If he continues his motion like this, he will be going towards infinity. Coming to another observation, let us take another value of theta. I'm taking theta as pi now. Taking theta pi now. Okay, fine. Again, I'm tracing the curve. This is real and imaginary axis. Now, he started moving from origin, and the very first step, he's moving 1 unit on the positive real axis. Fine. But at the end of first step, now he's turning himself 180 degrees. So he will start his second motion in the opposite direction. The distance that he's going to cover is 1/2 of the original one. Again, he will stop. Again, he will move 180 degree. He will spin 180 degrees and will start moving in the reverse direction, but by a distance of 1/3. Again, he will stop. He will start moving in the reverse direction now by 1/4, and he will keep moving like this. So you can observe it from here that the distance that he's going to cover in this situation when he's taking the spin angle is 180 degree is going to be least. The simple observation says that because he's moving in the back and forth direction on the same line, here the distance that he's going to cover is the least distance. So what is the second observation? If you want the least distance to be covered, here the least distance is being covered by the walker. So if you want the least distance to be covered, the angle of spin must be equals to 180 degrees. What about the next observation? We are coming to the next observation now. The next observation that now we are going to make after taking angle theta as 2 pi or angle as pi. The next observation that now we are going to take is, suppose he is moving the distance p theta. So what we have written, I am going to write once again that p theta wala form. So I will be writing p theta wala form once again. And before that, let us do one more observation. Another thing that is coming to my mind is, let us reduce the angle theta. So I'm going to reduce the angle theta now. So theta I'm going to make smaller. Theta is very small. Okay, theta very small. So let us draw the graph, the path traced by the walker. In the very first step, what he's doing is he's moving in the positive real axis by a distance of 1 unit. Okay, he stopped here. Again, he will start moving by spinning himself through an angle of theta, but I'm taking theta very small. The distance that he's going to cover is only 1/2. Now the third, again he's spinning himself by an angle theta, a very small angle, and he's covering the distance 1/3. Then he is spinning by an angle theta in anti-clockwise sense, covering a distance of 1/4, then 1/5, and 1/6, and so on. What we can observe here is, if I'm taking a very small theta, or you can say that if you're taking theta as small, the spiral is going to be large. So for smaller thetas, we are going to get large spirals. So if someone says that you have to move in the similar pattern, but the spiral that you have to make is very large, so you should take the smaller angle of spin. You take the smaller angle of spin, and the spiral that is going to form is going to be larger spiral. Now I'll come to the next observation. The next observation, as I told you, now I will be writing once again the sigma notation form of p theta. So what we wrote p theta as sigma n is from 1 to infinity cos n minus 1 theta upon n minus 1 plus iota sigma n is from 1 to infinity sine n minus 1 theta upon n. So here also let me correct it. What we wrote was n. So this is the sigma expansion or sigma notation of p theta that we wrote. What we are doing in the question, we are actually calculating the distance of the endpoint from origin. Distance means what? You actually calculated modulus of p theta. So observe carefully. I'm going to write here modulus p theta, which will be root over sigma cos square, sigma of the terms of all cos upon n whole square, plus again sigma n is from 1 to infinity sine n minus 1 theta upon n whole square. This is going to be modulus of p theta. This is actually the distance traveled by the walker after completing his total journey, or you can say the distance of the endpoint of the walker from the origin. What is the observation that we are going to make here? I'm just going to calculate modulus of p 2 pi minus theta. What will happen if you calculate modulus of p 2 pi minus theta? You will observe that it is going to be similar as modulus of p theta. From here, I can conclude that if p theta is some function of theta, the distance function, then this function is actually symmetric about pi. Then this is symmetric about the line x equals to pi or theta equals to pi. Symmetric about theta equals to pi. The function is symmetric about theta equals to pi. What does it mean? It means that whether you put theta equals to 0 and 2 pi, you're going to get the same answer. Yes, we observed it. You keep theta is equals to pi by 4, or you keep theta is equals to 2 pi minus pi by 4. You're going to get the same answer, and for the other angles as well. So this is also another important observation regarding the function that we are getting for the distance traveled by the walker. In case of graph, or if we trace the rough sketch for the corresponding function, what we can say is, I'll just be tracing the rough sketch because we don't have all the values. We are just assuming some of the values that we have calculated. With the help of that only, I'll be tracing the rough sketch of the function, the distance function. So suppose this is 0, this is 2 pi, and I'm going to trace now x equals to pi here. So here is x equals to pi. So what do you mean by the symmetry? Symmetry here actually indicates that if you have a graph, so 0 pi we have the value infinity, 2 pi also infinity, and we have also observed that pi we are getting the least value. The rough sketch, we can say that 0 pi it's infinite, pi you are getting the least value, and 2 pi also you're going to get it infinity. So well, this is the rough sketch that I have traced with the help of symmetry and some values that we calculated for the distance. So this is the graph that we'll be getting for p theta, or depending on theta how the graph behaves. So well, these are the 5 important observations that we have done in the question. So you can say that there are 4 additional or the bonus points that we discussed in this question. So that's all from my side for today. Thank you all for watching. Bye-bye for now.